Hello again, and thank you for joining me. This is Rob Wagoner, and today I want to talk about failover clustering in Windows Server 2012. We've made a number of improvements in Server 2012 over Server 08R2, but when we talk about virtual machines and high availability, it's still based on our tried and true server clustering model. Today I want to show you setting up a cluster in Server 2012. The first thing I'm going to do is show you my Iscsi Initiator because I'm using an EqualLogic Iscsi based SAN as my backend shared volume. And I've created a few naming conventions to hopefully make my life a little easier. We're going to be dealing with this witness, so I've created a witness volume, and then volume 1 and volume 2 on my SAN. And so these are my shared storage devices. When I look at Disk Manager, Disk 0 and Disk 1 are local attached disk. Disk 2, 3, and 4 are actually my Iscsi volumes that I've already connected and formatted. My witness drive doesn't need to be big. I actually just create a gig. You could probably get away with a couple 100 meg. I just go for a gig and keep it easy, right? I also have two additional volumes that I'm going to use in my cluster today. One is 401 gig in size. The other is 102 gig in size. And I've gone ahead and labeled these. One of the things about setting up a Hyper-V cluster is it's all about labeling things properly. When I look at my network connections and even my disks, one of the things I've run into as I've built so many clusters over the years is when I put a file on a shared volume, what physical volume on the SAN does that actually map back to? And so I've tried to put a few tricks in place to help me with that. First by labeling CSV1, CSV2, so you know what I want these to be. But the other thing I've done is the disk size, 401 gigabytes and 102 gigabytes. So that way, when I go look at this volume, no matter where it moves to, whether I look at it from my SAN Manager or from Disk Manager or even in Failover Cluster Manager, that's an immediate clue which volume this should be, so that in a production environment, it might not be as big of a deal as it is in a lab environment, but what I've run into is I'll actually accidentally delete the wrong volume. And so this way, I know which LUN on the SAN I'm truly intending to delete and don't accidentally delete the wrong one. So another one of those little tricks I've encountered. So let's create our cluster. The first thing we're going to do is move to our Failover Cluster Manager and start the Create Cluster Wizard. Originally, I wasn't a big fan of wizards, but when you really boil it down, there are only a few details we really need to know. Which servers, what are we going to name it, what's our IP address, what's our intent of the cluster. The wizard goes and makes all the other configurations for us and then confirms they work. Not only does the Create Cluster Wizard help us, but I truly love the Validation Wizard, and we'll touch on that in a second. What I'm going to do here is go ahead and identify the two servers I'm going to add. So I've already confirmed that the shared storage works between both servers. I create the LUNs on my SAN, map them to each machine. I'll then, in Disk Manager, online each one of them, format them, label them, and then actually offline it, move to the other server and do the same to make sure both servers can see the shared disk. I've selected my machines here, and take note of this validation warning. I love this. I started my career in Microsoft within the support space, and what we found was the majority of our support issues came down to initial configuration errors. So if there are things we can do to help reduce initial configuration errors, I'm all for it. What we're asking for here is, would you like to run validation tests against this cluster before we put it in production? You can say yes, and when you say yes and click next here, it'll start up this validation wizard for us. Or you can say no. Now, what I love about this is it says, no, I don't need to run the validation tests. I don't require support from Microsoft for this cluster. So if you're going to create a test cluster quickly, maybe you don't want to wait on the validation wizard. But if you're going to create a production cluster, I would highly encourage you to run the validation wizard, because when you call us for support, if you haven't run the validation wizard, that's one of the first things our support professionals will help you do. The validation wizard is an incredibly valuable troubleshooting tool because the validation wizard was built by our support teams in conjunction with our development teams. Our support teams who encounter all of the configuration setup errors that our customers run into, they funnel that feedback back to the development team. And so this validation wizard truly will validate your cluster. When you run it and your cluster passes, you have a fully supportable cluster, even if you're across hardware types. We've gone away from the list of supportable cluster hardware. because that list gets very complicated. And we've gone to this validation wizard. If you set it up and the validation wizard passes, you've got a supportable cluster. It's that simple. So we'll go ahead and ask for this validation wizard to fire up. And as you see, we jump right to the validated clustered wizard. I'll go ahead and run all the tests, because if I don't run all of them, again, I don't have a fully supportable cluster when it comes to calling Microsoft for support. Now, I'm going to expand this window here because it's now showing us all the tests that are going to be run. Again, all of these tests are tests that our support teams, in conjunction with our development teams, developed to make sure that your cluster is in the best position to be successful. And now we'll kick it off. The thing I really like about this is we're going to tell you in advance that your cluster is ready to use. We're going to prove that all the failover options work in advance. How do you really know if a cluster is going to respond properly in a highly available situation? Say we lose a node, say we lose a particular disk, say we lose a network device. This validation wizard proves all that out up front. So as you look at some of the competitive clustering scenarios, think about how you prove that that cluster is ready to go in production. Here, we're going to give you a printout. So what I'm going to do at this point is pause the video and come back to you after the validation wizard has finished. So now that the validation test is finished, we can look at our results. We have a results screen here, which will give us the high points of what worked and maybe what didn't. As you see, we have an IP configuration warning, or we can jump right into the full report itself. The great part about the validation wizard is it actually saves this report for later retrieval. So this way, even if we don't want to review it now, or if you call for support and the support professional asks you for the validation wizard results, they're easy to retrieve. But let's investigate this warning. So we drill into network, validate IP configuration, and as you can see, it gives us all the details here about our IP configuration. If we'll scroll down to the bottom of this section, it'll highlight its concerns. So this shows that I have multiple adapters on the same subnet. With the EqualLogic SAN, the way it's set up, my SAN actually has 3 NICs in it, but it wants all 3 NICs on the same subnet, because I just target a specific NIC and let the SAN do the load balance work for me. So what I've done is put 2 Iscsi NICs on each subnet so that I can get the load balancing across all 3 NICs on the SAN and across 2 different NICs in each host. I also want you to take note that we validate the matching processors. Both these processors are created by AMD. In your cluster, you can have a file share cluster or a DHCP cluster, and you can actually have different processor manufacturers, so AMD and Intel in that cluster. But for virtual machines, I can only live migrate between AMD processors or between Intel processors. I can't live migrate a running virtual machine from an Intel to an AMD or an AMD to an Intel. So I'll go ahead and close this. Now I'll go ahead and finish the cluster configuration. So I need to name my cluster and I need to give it an IP address. So I'll give it my name and my IP address, confirm this is what I want to do. Again, it shows me my nodes, my cluster name, my IP address, and it gives me this checkbox to add all of eligible storage to the cluster. I can leave this box checked and it'll add all 3 of those volumes I pointed out to my cluster as it creates it, or I could uncheck it and then manually add those disks if I want. I'm going to leave it checked and I'll go ahead and let it create the cluster for me. And now you can see the summary screen will tell us that the cluster creation is successful. So we can click Finish here and move back to the Failover Cluster Manager, and it'll go ahead and now load this new cluster for management that we just created. I'm going to stop here. I'll continue my discussion of setting up the Hyper-V cluster in part 2. Thank you.